Welcome to Spring LIB.
We want to investigate the family of polynomials given by the equation f of x is equal to 2x cubed plus cx squared plus 2x. And we want to find for what values of c does the curve have a maximum and minimum points. And then we want to show that these minimums and maximum points lie on the curve of y is equal to x minus x cubed. All right, so first let's go ahead and figure out what values of c will give a max or min. So first thing we need to do is take the derivative of f of x and then find our critical values by setting the derivative equal to 0. So taking that derivative there, we're going to get that f prime of x is equal to, well, we'll use power rule to take those derivatives. So we get 6x squared plus 2cx plus 2 is equal to 0. And we can go ahead and just divide all this by 2. And that would give us 3x squared plus cx plus 1 is equal to 0. And now we can go ahead and use the quadratic equation to solve for this. And just writing that out is going to be, and maybe I should go ahead and put the letters above it. So 3 is A, C is B, and I should put quotations around that. And 1 is C with quotations around that. So I'm just going to go ahead and write out what the standard quadratic equation is. So negative B plus or minus B squared minus 4AC all over 2A. And then plugging everything in, we'll get negative C plus or minus the square root of C squared minus, well, A is 3, C is 1. So we'll get 12 all over, and then 2 times A is 6. So we get this here for all of our possible solutions. And so the thing we're going to need to make sure is that this radical here is defined. So that's going to happen when, and let me go ahead and just move this up here, when c squared minus 12 is strictly greater than 0. So I can add 12 over. I get c greater than or equal to 12, c squared greater than or equal to 12. And then we can go ahead and take the square root. So that's going to say c is strictly greater than the square root of 12. Well, that's one solution, but if c is negative, we can also have that there as well. And then we can just multiply that negative over, and we get c less than or equal to the negative square root of 12. So these two here will be the values of c that will give us a maximum or min. So let me just go ahead and write down here. So if c is in the interval of negative infinity to negative 12, union 12 to infinity, then this here will give us a maximum or a minimum for that class of functions. All right. Now, the next thing we want to do is to show that these maximums, so remember the max or min that we have is really this value over here. So we want to show really that x equal to negative c plus or minus the square root of c squared minus 12 over 6. Let me go ahead and make that more like negative 12. So minus 12 We want to show that this gives the same output for our function f of x as well as this line y minus x cubed. So let's just set these two functions equal to each other and see what we get. So I'm going to set f of x equal to y. So f of x is 2x cubed plus cx squared plus 2x, and y was x minus x cubed. So let's just see where these two lines would intersect. So I can subtract x and add x cubed over, which would give 3x cubed plus cx squared plus x is equal to 0. Let's go ahead and factor out an x. So we get x times 3x squared plus cx plus 1 is equal to 0. So this here tells us by the zero product property either x is equal to 0 or 3x squared plus cx plus 1 is equal to 0. And you might notice that we've already solved for this, because when we looked at the derivative over here and we set it equal to 0 and we divided it by 2, we ended up with that exact same quadratic. So the solutions for our maxes and mins will all be the same. So you could go ahead and solve this and then do it that way, but I think this is a good place to just go ahead and stop.